stream it.
That's seeable.
Huh?
Is that readable?
I don't know.
I feel like that's readable.
Ask the audience. Figuring out the streaming issue.
Okay. Drop that down a little bit.
Where do I go to check that, Chris? Yeah.
Would a dark theme be good or a bright theme?
I think darker room. And do the lights all have to go out, or can a portion of the lights closer to the projector go out?
Will that mess up this video recording?
I mean, I can just do.
Or video recording is more what we see on the screen. These like pictures in this.
There you go. That's. You can actually see that now. Cool.
Wrong way.
Whoa. No, we were good with. There we go.
Yeah.
All right.
That's nice.
Yay! All right. Record time. All right, you.
All right, so we'll kick it off and we'll figure out the other technical issues as we go. But thank you everyone for joining this month's Philly Azure Meetup. So this month we have Ned Belvance, Microsoft MVP, and he's going to talk a lot about AKS, which is awesome. He's the only speaker tonight, so take as much time as you like.
Ask as many questions as you like. I might know the answers to at least some of them.
Do you need a full walkthrough end to end? We've got time. As always, we are recording this and will be posted to our YouTube channel, and we are broadcasting live on Mixer, Twitch, and YouTube Live. And hopefully all of those streams are working, and if not, we're going to work to fix that, but that doesn't really impact you at all. But those of you who are watching online, we're working on fixing the other ones. But the recording should still be good. So we know we're running late. Without further ado, Ned, feel free to introduce yourself and go ahead.
Hi, I'm Ned Belvance. I think he did all the important stuff. So we can get right to the topic. So what I wanted to talk about today was the Azure Kubernetes service at just kind of a fundamental level. My understanding is next month there's going to be a hands-on lab type situation where you'll get to actually deploy some applications and those types of things. Today's really just kind of what is this service? What is it composed of? What are the good to knows when it comes to different components that it's composed out of? So this is fundamentals of Azure Kubernetes service. And so what I want to talk about is first principles, so just level set where people are at in their Kubernetes knowledge. Then we can talk about some fundamentals of what Kubernetes is, what are the components that comprise it, and then we can dive into AKS fundamentals, which are going to be slightly different, but based off of Kubernetes, obviously. And finally, what are the components that make up AKS? And that's where we're really going to do deep dive into what I think are the four main components: identity, compute, storage, and networking. What we're not going to talk about, so there is some stuff that we're not going to cover, partly because of the upcoming lab and partly because it's not necessarily relevant. We're not going to have an argument about which is the best container runtime. If you like Docker or Rocket or Cryo, I'm not going to feel one way or the other about it. We are not going to talk about CI/CD pipelines. That seems to be the magic bullet that everybody likes to spew out at the moment. Doesn't matter for our particular conversation, so we're not going to talk about that. We're not going to talk about Git branching strategies for some weird reason. We're not going to talk about application development. I know a decent number of you in here are application developers of some shade. We're not going to talk about the app dev side of Kubernetes. Yes, it's awesome. Yes, you can do cool things. That's what next month is for. This month is, hey, there's some stuff going on behind the curtain. Let's talk about that. We're not going to talk about service mesh. Well, no, we might talk about service mesh a little, but I'm going to try to avoid that topic as well. And we're not going to talk about the Game of Thrones Season 8 now or ever. So now that we're feeling good about that, let's talk about first principles. And I just want to do a poll of people who is using containers today for development purposes, production, whatever. Is anybody using containers? Okay. You're using containers. That's exciting.
But I work here.
Oh. I mean, yay. Okay. So Who's using Kubernetes today? Anybody? No? All right. So I guess my next question is pretty irrelevant. Who's using Kate's in production? Has anybody launched Azure Kubernetes Service, messed around with it a little bit, click the buttons, see what happens? All right, we got a couple people. But I would assume by that less than enthusiastic reaction that none of you are currently using AKS for production workloads. Would that'd be fairly accurate? Okay. Good. Well, here we're going to get some background. You'll feel comfortable about it. And when you have to go to your boss or higher up and sell this up the chain, you'll be well armed for that. So, because a lot of you haven't worked with Kubernetes before, we'll just dive into some fundamentals of what Kubernetes is. At its core, it's a container orchestration platform. So the idea is you've bundled your application into one or more containers, probably some sort of microservices, and now you need a platform to run all that stuff on. And Kubernetes is one of those platforms. And another version of container orchestration was Mesosphere, and then another one was Docker Swarm. So if you've messed with Docker, you might have gotten into Docker Swarm. The idea here is basically, I will tell you how many of these containers I need running, and then you will make sure that they get scheduled on nodes and run. And then if the health of that particular container or service or application dips or has trouble, you're going to try to remediate that by spinning up a new container and honoring whatever I request in terms of resources. Kubernetes is open source, 100% open source. It's part of the Cloud Native Computing Foundation. It was originally written by some people from Google based off of their experience running their Borg platform, which was their internal platform that kind of did essentially what Kubernetes does in the open source community. They then donated it to the CNCF, and now some of the biggest contributors to Kubernetes are Microsoft, Red Hat, Google's still very heavily in there, and a bunch of other big companies as well as individuals all contribute to try to make Kubernetes the best orchestration platform it can be. What does it do? At its core, it deploys containers in pods. So the smallest unit you can deploy something in Kubernetes is the pod. And a pod is composed of one or more containers. Often it's just one container, and you might be like, well, why don't you just call it a container? But the idea is that if you can have multiple containers in a pod, they share the same IPC space, so the inter-process communication, they share the same space, they can talk directly to each other, and they share the same localhost network space, so they can talk to each other over that. So if you wanted to add a sidecar proxy to your application, if you wanted to add something that does logging, like FluentD, to your application, you could put that FluentD sidecar proxy as a container next to your regular application, and they'd function together in a pod. So that's the smallest composable unit that we can use. Kubernetes uses a declarative style configuration for telling it to create resources. So generally you'll write out what you want in a YAML file, and you'll submit that to the API endpoint of Kubernetes, and Kubernetes will go create whatever was in that manifest. It's usually just that simple. The main command line tool, the one I'm going to be using today, is called kubectl or kubecontrol or kubectl, depending on which one you prefer. I like kubectl because it's cute, but you can call it whatever you want. I have no particular compunctions against one or the other. It is all API driven, so the way that you interact with Kubernetes is through the API. You don't, SSH into boxes and make configuration changes. There's no CLI that's talking directly to a controller or some micro component of Kubernetes. Everything should happen through that API front end, and then it distributes the work or the instructions out to the different components within the cluster. Generally speaking, batteries are included for a lot of the functionality. It has a scheduler. It has a way of controlling different components in terms of replication, replica sets, deployments, services. But it also allows you to add your own components through plugins. So for instance, in AKS, they are using a plugin that, with the cloud controller, that allows it to deploy storage as well as networking resources like the load balancer. So that's high-level view, key concepts for Kubernetes. You could take a whole course on it. I tried to distill into one slide, so I hope I did it okay. In terms of the actual components that make up a Kubernetes cluster, it starts with the master nodes. So you're going to have one or more nodes that work as the master nodes for the cluster. And on that, it starts with that API service. So you've got an API service that's listening for requests. And then in the background, you've got a controller manager, which literally manages other controllers within the Kubernetes environment. So there can be a bunch of different controller types below that, but it's kind of in charge of overseeing all of them. You've got the scheduler, which determines when services and pods are going to be scheduled on nodes to run. You've got kube proxy, which is part of the networking stack and forms the networking connection between the pods that are going to run and the external world of networking. You've got the kubelet, which is the service that runs in the background that sort of coordinates the communication of the cluster. And then all the configuration information and state of the cluster is stored in some sort of key value store. In most cases, it's etcd. So that's everything that sits on the master node. The things that sit on the worker node, it's a lot simpler. You basically have kube proxy, which handles the networking for your pods. How is it going to talk to the larger world outside of this worker node? And you have the kubelet, which is that process that runs, or that service that runs in the background that's coordinating with the rest of the Kubernetes cluster, talking to the API server, the scheduler, the controller manager, all those different components. And then the rest of it's taken up by your container runtime, which could be containerd. That's the most common of them. And within that container runtime, you'll have one or more pods running on your node. So those are the components. I'll stop here if anybody has questions about where everything fits in here. Make sense so far?
So you say the container D, so that is a runtime for container.
Mm-hmm.
So is it like a process running, container D, or is it just a framework in which the pods are running? What exactly is container?
I mean, so the pods will run as individual service processes, but containerd is the runtime in which they're packaged.
Okay.
And there's different container runtimes out there. This is probably just the most common.
Each pod will have one or more containers in that.
Right, right. So within each pod is one or more containers. In terms of the master node, there's always an odd number of master nodes. It's usually, you know, 1 for development and then 3 or 5 for production and other environments where you need that master node around all the time. But for development, you can just have a single one, and you could actually use it as the worker node as well in a really small configuration if you want to run something like Minikube on your laptop. Okay. AKS. So AKS is Microsoft's managed Kubernetes service that runs in Azure. And the graphic we've got here shows you kind of roughly what's under the purview of Microsoft and what's under the purview of you as the customer, what you can see. There are a number of other container services within Azure, so to avoid confusion with all those other services, there was a service called Azure Container Service, which is deprecated. As far as I know, it's deprecated. Yeah. That allowed you to deploy Kubernetes, Mesosphere, or Docker Swarm into your own environment. It wasn't managed. It would do that initial deployment, and then it was up to you to do the upgrades and the maintenance for it. AKS is not that. It's also not Azure Container Instances, which is the ability to just spin up a single container instance. It's basically containers on demand. It's very cool. You can extend out to ACI through AKS, but that's a whole other topic that we're not going to get into. It's not Service Fabric, which also allows you to run containers, and it's not App Service, which also allows you to run containers. It's its own thing. So just to sort of differentiate there a little bit. Microsoft is in charge of running those master nodes. So all that stuff I showed you that's running the master node, you don't have to worry about that. That's not your problem anymore. Microsoft is going to manage that. It's going to manage the updates for the cluster, making sure that that master node is available. there's a lot of moving parts when it comes to the master nodes. The fact that you don't have to worry about it is kind of nice. You can see the worker nodes within AKS. Now, how much you want to manage those is up to you. You do have the capability of remoting into them through SSH, or if you're running Windows containers through RDP. You can install additional components on them. Maybe you have a corporate directive that you have to have a certain antivirus and everything, or a certain logging tool, or what have you for those worker nodes. You could add those on. When you spin up your AKS cluster, it's going to provision those worker nodes for you initially, and then you could make changes as you see fit. Probably don't want to mess with them too much so you don't break any of the communication back to the master nodes. And those are running the things that I talked about before, which is the kubelet, the kube proxy, the container runtime, and then containers in the form of pods. So you have full access to those worker nodes. When it comes to what's actually being used in Azure, the construct of the worker node is an Azure virtual machine. So they didn't try to reinvent the wheel here. It's using the constructs that we all know and love in Azure. And the first is the Azure virtual machine is that worker node. And you can use a bunch of different families of Azure VMs to serve as that worker node. So if you have a workload that's going to need GPUs, you can actually select that family of worker nodes. They're going to be rather costly, but you could do that, and you'd have GPUs available to your containers. Within the Azure virtual machine, it's using Azure's virtual network interface to communicate out to the larger world, and that is plugged into an Azure virtual network. On the storage side of things, for storage, by default, it has access to Azure Disk, managed disk for its backend storage. When you ask for a persistent volume, that's where it will create it by default. You can also add Azure Premium Disk, or you can hook it into Azure Files, which is a different service within Azure that is specifically around using SMB to serve up file shares. And you can use Azure Files either at the standard or premium tier. You can also bring your own storage if you want to spin up an NFS server in this virtual network and connect that into your AKS cluster. You could use that for your storage as well. So you've got a lot of different options when it comes to storage, but by default, the two services it tends to use are Azure Disk and Azure Files. So those are the high-level components for AKS. So I wanted to drill down into those a little bit with actual examples. So first, we'll talk a little bit about how identity is handled within AKS. But before I do any of that, I just want to go through the steps of how you would spin up an AKS cluster in your environment. So jump over to the portal and go to all of my existing AKS clusters. So I already have five. Wow, I have five. Hey man, there's been a lot of demos. Things happen. And when you can just click add, it makes it super easy. So to deploy an AKS cluster, all you have to do is go to the portal and click add, and it's very easy. You can pick an existing group, or you can create a new one. So let's say I create a new group called Billy Azure 4. I'll give the cluster, I've just been incrementing, so we'll call it PA4, tell it what region I want it in, and then it'll ask you which version of Kubernetes do you want installed on your cluster. You'll note the default is 1.12, 1.13 is there. That's a stable build. 1.14 is stable in the Kubernetes world, but it's still in preview in Microsoft's world because they're still doing their due diligence on it. I believe 1.14 is what brought Windows container support fully into Kubernetes as a GA thing. But we'll just select 1.13. The DNS name prefix is going to be the publicly accessible endpoint for the cluster. And then you have to tell it how many worker nodes do I want to start out with in my cluster. You can scale this up and down. and what size and family of VM do I want to use. By default, it picks DS2 V2, and I don't know why. It's actually a little bit cheaper to go with the V3, but it still picks V2 for some reason. The smallest you can scale it down is one node. So you can deploy a single node, and the only thing that you're going to pay for out of all of this is that one VM. So the master nodes that Microsoft manages on the back end, you're not getting charged for any of that. So if you just want to test this out, do a dry run, pick the smallest VM size you want, the cheapest one. You can go with a B series, which are like $30 a month or something, and strip it down to one node, and you'll have a functioning AKS cluster that's going to be relatively cheap for you to run.
If you delete it when you're done, you're done. Right?
Delete it when you're done, or alternatively, you can go into the resource group it creates, and I'll get to this in a moment, but it creates a resource group to house that VM. You can go into that resource group, find that VM, and just stop it and start it when you want to use it again. You still get charged for storage, but it'll stop getting charged for compute time. So yeah, if you're really trying to do this on the cheap, that's one way to do it. Then it'll take you to the next thing, which is, do you want to do virtual nodes or VM scale sets? We'll get into that in a little bit, but let's just leave those two disabled. So in order for AKS to talk to the rest of Azure and ask it to do things, we saw that it's using Azure Disk to provide storage. It needs to reach out to Azure and say, hey, I need you to provision me a disk because I got a request for storage. You need to create a service principal, which is basically a service count in Azure AD it's going to use to interact with the larger Azure world. By default, it creates a new one for you. You can create one yourself. You just have to make sure you're assigning it the correct level of permissions to the subscription where it's going to be provisioning resources. So it's obviously easier to just have it, create a service principal for you. By default, it also enables role-based access control. I'm not sure why you would want to turn that off. Maybe you just don't like role-based access control. Generally speaking, makes more sense to leave that enabled. Then it'll ask you about networking, and by default, it goes with basic networking. We'll talk about that in a little bit. And also, it has HTTP application routing turned off. Monitoring, it's going to ask, do you want to take the logs from your containers and put them into a log analytics workspace? I'm going to say no on that one. Tags, I do have a tag I'm using for all these, so I remember to delete them. There we go. And then the last thing, review and create. Validate. And I think it actually creates the service principal as part of the validation process. So you may end up, if you run this and then cancel it, you may end up with that service principal lurking in your Azure AD. Not a bad thing. If you're cleaning up service principals and you're like, oh, why are there all these service principals? That could be why. All right, and we'll click create, and that'll go off and initialize this deployment. So that's the standard process for deploying one through the portal, which is the easiest way to do it. You can also do it through the Azure CLI. You can do it through PowerShell. You can do it through direct ARM templates or direct API calls if you're really into that sort of thing. All the typical ways that you would deploy something to Azure are all available. I just wanted to show the easiest way of doing it. In terms of identity, I kind of talked about this a little bit already, but it does create that service principal and give it permissions. So if I go over to, commands you won't remember, let's connect into Azure using the CLI. And we can look at one of the clusters that I've generated. Okay, and I want to grab, we'll do PA1. So I'm just running a command AZ AKS list that'll list out all of my AKS clusters that I have, and I'm going to query specifically on PA1. So that's the one I want to give me information about. And when it finishes its query, eventually, what it'll do is it'll show me within the properties of the cluster the service principal that's associated with that cluster. So if you needed to figure out which service principal is associated with which cluster, you can't see that within the GUI. That's something you actually have to query through the CLI, or I guess you could query it through PowerShell as well. So here we go. In the description here, see it says service principal profile and the client ID. So that is the object ID of the service principal that was generated when I created that cluster. And if I take that, drop it in here, and basically I'm just gonna run a, oh, well, it didn't copy. That's not helpful. There's this weird bug in VS Code where it doesn't copy and paste right. I got to put an issue in about that.
It's open source.
No. I mean, I can log the issue. I thought you were going to say that I could fix it.
Well, you could fix it too.
Yeah, no, that's not going to happen.
Just do the first part.
So what I did is I just asked to show the service principal that's associated with that. And if you take a look at the service principal name, the way that it names it is it basically takes the name of the cluster that you created, adds SP dash, and then a timestamp of when it was created. That should be good enough to be globally unique, and creates that service principal. And then associates it with the correct permissions that you're going to need to be able to provision resources within the AKS cluster. So that's one thing that gets created in Azure that's good to know about. AKS also has the capability to do user authentication using Azure AD. And in order to do that, you have to create two more service principals. One to query Azure AD to get a list of users, and the other one to perform the actual authentication for that user. You need to specify that when you create the cluster that you want to use Azure AD for an authentication source. As far as I know, there's no way to configure that after the fact, at least not with any of the Azure CLI commands. Maybe that's coming to the portal and the CLI sometime in the near future. So that's,
that
yes.
would cover any application that you have in your cluster.
So that is more for users who are going to be interacting with the cluster. So administrating or even using kubectl to deploy resources. So let's say I wanted to give you, a developer, access to deploy resources in a namespace called development. And I want you to use your Azure AD login to authenticate to the Kubernetes cluster. By enabling Azure AD integrated authentication, you could do that, and I could create a role on the Kubernetes side that says when this user logs in, they have this level of access to this namespace and nothing else within the cluster, so you couldn't mess with prod or staging or whatever else exists on that cluster. So that's the idea behind it. Sure. So that's kind of identity, those two components. What was the... So next, it probably makes sense to talk about compute, because compute's important. Let's see if our deployment has finished. No, so we're just going to go to a different cluster. So a good example here, I've got my PA1 cluster that I stood up at some point in the last couple days. And it tells me a little bit about what's going on in this cluster. It tells me that I'm running 6 total cores and total memory of 24, but on the dashboard it doesn't tell me how many VMs that actually is. So that could be one VM that happens to have those specs on it, or it could be several. I can look at scale, and scale is what will actually tell me how many VMs I'm currently running in this cluster. So you can see the node count is set to 3. I've got 3 Azure VMs that make up this cluster, and they're all of the D2SV3 size. You can add nodes, you can remove nodes. Obviously, if there's pods currently running on one of those nodes and it kills those pods. If those pods are part of what's called a replica set, which is basically a way of telling Kubernetes, I always want this number of pods for this application running, it'll create a new pod on another node that's available. Hopefully your application was stateless or is okay with being cut out of running. you cannot change the family of the Azure VM. So you're a little locked in that case. And that's part of the reason that Microsoft introduced node pools, which we'll get into in a second. If I want to see the actual VMs that are backing this thing, let me go into dashboard. And so the resource group that I created that cluster in was Philly Azure. So that's this one right here. When I created a Kubernetes cluster, it created a separate resource group for the things that make up that cluster. And the naming convention is MC underscore, the name of the resource group that the AKS cluster lives in, the name of the cluster, and then the region in which it was created. So it will create this resource group automatically. If we go and look at what's in this resource group, and I'll just kind of sort it. That's a terrible view. That's better. Okay. Down at the bottom, it has my 3 virtual machines. And they're all part of an availability set. So for I don't know if everybody's familiar with what an availability set is in Azure. For those that aren't, an availability set basically says, any VMs who are in this availability set, I want you to schedule them in separate fault domains and update domains. And you can specify how many fault domains and update domains are in that availability set. So in this case, I've got 3 VMs, and I think that the default for fault domains is like 5 or something. So what it means is that these 3 VMs are running in different fault domains within the Azure data center. So if something were to happen in one of the fault domains, it wouldn't take down the other 2 VMs. That's the general idea behind availability sets, which is not to be confused with availability zones, which is another thing that we'll get to in a moment. But yeah, they're part of an availability set, and these are the 3 virtual machines that make up the cluster. I can click through on one, and it looks just like a regular Azure VM, except that it has a whole bunch of tags associated with it that let Azure know some information about that virtual machine, like who created it, what's the orchestrator version, what's the AKS engine version, those types of things. It does not have a public IP address by default. I can start and stop it if I want. I could connect into it if I was on the VNet where this VM resides, but because it doesn't have a public IP address, I can't get to it from the outside directly. So that's looking at an individual VM. If I wanted to take advantage of that node pools thing, what's that crazy thing? I actually have that enabled, I think in PA too. I hope I'm right. So node pools is a preview feature, but the idea here is basically you can create a pool of nodes that are of the same family, and then you can scale that node pool separately from other node pools. And you can use the properties of that node pool are accessible in Kubernetes, so you can specify using what's called a node selector to say, I want this application or this deployment to run on this type of node. So that example I gave earlier where maybe I have some that are GPU enabled, I could create a node pool of GPU enabled VMs and only select those nodes for workloads that need the GPUs. So you can see I've got one node pool here that's got 3 nodes in it. If I want to add another node pool to this AKS cluster, all I have to do is say, I want another node pool. I can go node pool 2, tell it I want to use Linux, choose a size. So this is where you could select whatever VM size makes sense for your node pool. So maybe I want a bunch of really small nodes. And then how many nodes do I want? So maybe I only want 1 node in this node pool, click add. You can also, when I created it, I didn't specify a Windows authentication profile, so I can't do it right now. But you could also create a separate node pool in the same cluster of Windows machines. So within the same AKS cluster, you could have Linux and Windows workloads running, which is kind of interesting, and that's also where preview feature, so may or may not be working exactly. So node pools is what gets you out of that. I can only have one type of VM in my AKS cluster. Now you can have multiple different types of VMs within the cluster. The other thing that node pool uses is VM scale sets, as opposed to using just regular Azure VMs. So if we go into the resource group that this cluster is using, should be PA2. Okay, that's the one. You see, rather than having a bunch of VMs in here, it just has two VM scale sets. One's the node pool that I started with, and the other one is the one that's being added right now. So it's now using VM scale sets instead of scaling by adding additional VMs manually, which kind of makes sense when you think about what you're actually doing with this. It probably makes a lot more sense to use VM scale sets. I guess that just wasn't available when AKS was first rolling out, so that's why they chose to do it that way. So that's probably everything under the compute umbrella, but does anybody have questions about what's happening on the compute side when it comes to AKS and Azure?
On the Windows VM that you mentioned was in preview.
Yes.
How much control do you have over the configuration of that?
That's a great question. I don't know. I haven't been able to get it working yet. Well, not be able to get it working. So when you create the AKS cluster initially, for Windows enabled clusters, you have to do it through the CLI, and there's some additional parameters you have to set to enable the Windows feature. You also have to register that feature before you even spin up the cluster. So there's a whole knowledge base article on how to get Windows VMs enabled. And essentially you have to create an authentication profile that has a username and password that it'll use for all of those machines. For the Linux ones, it automatically creates an SSH key pair for you. And then you can get the SSH key pair through the Azure CLI after the fact if you want. I believe the only supported operating system is Server 2019. So whatever you're spinning up, it's going to be Server 2019. So yeah, you can't go, I don't think Server 2016 is one of the supported operating systems. Someone can fact check me on that, but I believe 2019 right now is the only one. Do you know, Tim?
The VM that you spin up, you can access it just like a normal VM, or Microsoft restricts because of the platform as a service?
The worker nodes you can remote into. So that Windows authentication profile that you create, that username and password will work. You'll have to enable RDP on the network security group rules, and also have to be in the virtual network where that node resides to get into it. But all of those things are entirely possible. So you could go in and poke around and see what it's doing. I'd recommend not messing around with any of the Kubernetes configuration side of things, because you don't want to break the worker node. But you can certainly go in, and if, like I said before, if you need certain monitoring tools or certain antivirus tools or whatever your company standard is, you could go in and install those things after the fact.
So when you deploy your container, do you tell which node you can use to deploy the container because you have a different node pools?
Yes. So when you're sending the pod deployment, you can add a node selector and say that I want nodes that are tagged with this type or this label. And obviously the Windows nodes will be tagged differently than the Linux ones. And the node pool name is an attribute that you can see in Kubernetes and say, okay, I want to select that particular node pool for my work. You generally don't select a specific node to deploy on. I guess if you have a worker node pool that only has one node in it, you kind of know which one it's going to go on. But the whole idea of the orchestration is you're letting Kubernetes make the decision on which node makes the most sense to put that workload on. It can look at, I'm requesting this much memory, this much CPU for my pod. It'll look and say, okay, this is the node that has that capacity free, so I'm going to schedule it on that one.
Did you talk about ones that are together versus ones that you never want together, like taints versus.
No.
Okay, so that-
Do you want to talk about that?
No, you go ahead. It's kind of just an add-on to that question, right? He asked, where can you schedule it? And then I thought, oh, well, you could talk about sidecars. You could talk about, which I think you mentioned earlier.
Yeah.
You could also say these only go on the GPU ones.
Yeah.
You could also say the ones where you taint. You say these can't go on there. Like the default, I think, is the taint on the master, right? So you can't. deploy
Right.
that.
Yeah, you don't generally don't want to deploy anything on the master, so you can taint the master and say, no, you never deploy pods on there. You can do that with other nodes as well. If you want to say, actually, these 4 different node types are fine, but I don't want you to deploy on this node type ever. And that for the GPU-enabled ones, generally you don't want any workloads but a very specific one to go on that because of the expense of the resource and what it's going to be running. So yeah, there's a couple different strategies.
And also with containers, like if you're putting out a container that does your site, and then you're putting out a container that does caching, you can set it up so they both would go to the same node. So you say, okay, website 1 and cache 1 go together, website 2 and cache 2 go together. So they're paired essentially.
Yeah, you
So
can
they'll
create
always
sort
go
of
to the same-
affinity
Right,
sets,
that's what it was
basically.
before.
Yeah. So you can create affinity between pods and say, these pods should live with these because they're tightly coupled. And really then the decision comes down to how tightly coupled are they? Should they be in the same pod together? Or should they just be on the same node together because they share so many things in common? You don't want the latency of going between separate nodes in your cluster. So that's more getting into the Kubernetes deployment methodology side of things. So that's compute at a high level. I think, yes.
If we're covering VNets here,
We are.
is that internal to AKS, or is that, does it create one there for you, so you get it for free, or is that just because you didn't identify an external VNet to use?
Excellent question. And we're moving to the network section now. So perfect segue. Well done.
Good setup. Thanks.
All right. It's almost like I planted you there or something. So when we went through that initial deployment of our brand new PA4 Kubernetes cluster, it didn't ask us anything about networking except do we want to use basic? And when we said basic, it said, okay, I'm going to go out and create a VNet for you. And if we go into the networking for it, it's going to let us know it's using the basic network profile, which is, I don't know why it says Kubnet, it's KubeNet, but, and then it gives us some IP addressing information about how it set up the networking. If we actually want to look at what networking was configured, we can go back to our, where's that? Our friend, the resource group. And so this is the resource group that aligns to that Kubernetes cluster. And we can see it did in fact create this AKS VNet on the back end automatically. And within that VNet, it's using an address space of 10.0.0.0/8. And if anybody's familiar with networking, you know that's basically the biggest address space you could possibly give yourself. So it's a massive address space, but in terms of what's actually being used by the cluster, it is using a single /16 for the AKS subnet. So out of this gigantic /8 names network space we've given ourselves, we're only using a /16 for the actual AKS subnet. So you could add other things in here, but this is what it deploys by default. To answer your question, could I add this to an existing subnet, to an existing network? Absolutely yes. So when we went through our configuration, we can specify, I actually already have a VNet that I'm using, and I want to deploy the AKS cluster on a subnet in that virtual network. There are some things you have to consider when you're doing that, and most of it's around IP address spacing. So I did mention that there's 2 types. Well, no, I didn't mention, but now I'm going to mention that there's basic networking and advanced networking when you're deploying your cluster. This is an example of basic networking, and what that means is it's using the KubeNet plugin for its networking, which is just the basic vanilla Kubernetes plugin. What that's actually doing on the networking side of things is each node in your cluster gets an IP address. So if we look at this is subnet, maybe it'll give me the, no, it's not. All right, we'll go back to this. So here's the network interface for the one worker node that we put in there. We can see it has a private IP address of 10.240.0.4. The AKS subnet that it's deployed in is 10.240/0.0/16. Each node that you add to this cluster will get another private IP address in this subnet, which is fine. That's all the network addressing that the basic needs. When you deploy a pod inside that node, it's using an internal IP address space specific to that node, and the pod gets an IP address there, and then it uses NAT to NAT out to the larger subnet. So in terms of how many IP addresses you need when you're using basic, it's how many worker nodes, what's the maximum number of worker nodes you're going to have in this cluster. So if the maximum is, well, this gives you 65,000, you're not going to hit 65,000, but if you used a much smaller network of like a /24, you'd be limited to 256 nodes, or 254 once you take out, or even like 252 maybe, once you actually take out all the other networking things that happen. You'd be limited to that number of nodes within that space. That's for basic networking. There's an advanced networking feature that uses a different network plugin on the Kubernetes side. It uses the Azure Container Network, CNI. Yeah, I had to remember the acronym. It uses the Azure CNI to do the networking instead. And what that means is, in addition to all of your worker nodes getting an IP address in the subnet, every single pod that gets spun up also gets a private network address in that subnet. It can make networking much simpler, and I think a little bit faster because it doesn't have to do the NAT. But it does require a much bigger IP address space. The current maximum for pods per node is like 110 pods, I think. It's something like that. So if you imagine if you've got a 3-node cluster with 110 pods per node, that means you're going to need 3 for the worker nodes themselves, and then 330 for the maximum number of pods you could run, so you need address space of at least 333. It's not a huge network space, but that's only 3 nodes. If you start scaling up to, 100 nodes, you're now going to need a much bigger IP address space. And if you're putting this in a VNet that your networking team is managing, they might go, whoa, I'm not giving you a /16 for your crazy AKS project. You get a /24, and then you're not stuck, but then you're probably going to end up using basic networking. So it's important to kind of make that decision up front, because I don't think you can change it after the fact either. That's sort of I'm deploying this cluster, and this is the decision I'm making now.
It also doesn't include when you start registering services, things like that. That has to be
Right, because the services get an internal IP too, don't they? Yeah. Okay. So in terms of networking, each worker node is going to have a network interface, which is what we're looking at right now. That gets an IP address. Any services you create in the cluster would get an IP address. Any pods you create would get an IP address. So that could end up being a lot of IP addresses depending on how you're deploying things. In terms of load balancing, if you create a load balancer in your Kubernetes deployment, it goes out and creates a load balancer or uses an existing load balancer within Azure. By default, it uses a basic load balancer, but if you're deploying it with availability zones, it now uses the standard load balancer instead. So just to give you an example of that, I have a load balancer example.
The default is public. If you're doing it in a VNet, you have to use the special nomenclature for an internal load balancer.
I have an example for that. Got you covered,
just
buddy.
throwing that out there in case somebody accidentally VNets something off and then explodes to the public IP.
Okay, so let me just hide the prompt for a second. So I talked about before, when you're doing deployment on Kubernetes, you define everything within a YAML file, and then you submit that YAML file to the Kubernetes cluster. So in this one, I've got 2 components. This first component here is a deployment. So the kind here is deployment. what am I deploying? I'm deploying Nginx, and this is really simple. In the spec, I'm telling it I want 3 replicas of this deployment running. So basically 3 pods is how many pods I want. I want to, where is it? Okay. I want to give it a label of Nginx. The app label is going to be Nginx. And for the containers that make up each pod, I want it to be called Nginx pod, and the image I want to use is the Nginx stable Alpine. So this is a very small image that's easy to pull down, and I'm going to tell it to expose it using port 80. So that just spins up the pods, but it doesn't actually create a service that's going to expose this to either an internal endpoint or a public endpoint. And that's what this second component of the configuration is. I'm telling it I want to now create a service to expose these pods. The type here is load balancer, so I'm telling it I actually want you to go and create a load balancer on your cloud platform, whatever that might be, because Kubernetes doesn't necessarily know which cloud platform you're using. I want you to expose port 80 for this service, and I want you to select any pods that have the label app and app equals Nginx. So that's how you tell it, these are the pods I want you to expose under this service. So if we go ahead and, actually I don't know which context I'm in at the moment. So before I do anything, because I have so many different clusters, I need to figure out which cluster I'm currently referencing. I'm doing PA1. So let's do this on I'm on PA2 right now. Let's move this to PA1 first. And maybe I'll even remember the command. Set context. Okay, so now I'm using that PA1 AKS cluster, and I'm going to do kubectl apply. So that's telling it I want to, apply a configuration. -F tells it I've got that configuration stored in a file, and my file is load balancer example.yaml. So I'll tell it, go ahead, deploy that out, please. And it comes back and says, all right, I created that app deployment, and I created that service for you. And if we want to see what it actually created, we can do kubectl and get the pods. And there's my 3 Nginx pods. They're already up and running. That was kind of fast, but it is a very tiny image. And then I can get the service by doing get svc. And we can see it has both a cluster IP, so that's its sort of internal IP, and then it also has an external IP, which is, like Tim was saying, is the default. When you create a service and say load balancer, it assumes you want a public IP. If we go to that public IP, we get the Nginx welcome screen. So I basically created 3 pods, all running Nginx. They're load balanced behind a load balancer. And if I go to that public IP address, I get what I'm expecting. So let's look and see what actually got created within the cluster itself. So if I go back to my dashboard, and we're going to go into that resource group, there it is, that's associated with the cluster, and I pop that up a little bit, and we scroll down. Where is it? I don't see it. Should be a load balancer in here. I agree. There should be a load balancer. Maybe the portal's lagging. Or we could just look at load balancers. There's always another way around it. Okay, it's not showing up yet for some reason in the view, but there it is in the resource group. Okay.
It exists for real, just not not in the portal yet.
Right, for whatever reason, the resource group didn't update with that resource in it, but it's actually in that resource group, so whatever portal.
In the quantum world.
Well, because the reverse wouldn't really work.
No, not very well. So this is the load balancer that it created on the fly to expose this service. If we look at the backend pools for this load balancer, so this is what's serving, what's backing the load balancer. Oh, you can see it's got one pool running here that's got my virtual machine in it, and I can look at the load balancer rules and see that there's a bunch of load balancer rules in here, different strokes for different folks. But this one is basically saying TCP port 80 on the front, 80 on the back. That's connecting into my service. So on the fly, it's created this load balancer. If I delete every single service that's associated with this load balancer, Azure will clean up that load balancer in the background and delete it out. Which means that the next time you go to deploy something to that cluster, it will have to recreate a new load balancer, and there's a little bit of lag there. So the very first time you deploy something, there's a little bit of lag between when you ask it to create that load balancer and when it actually creates it, because in the background it's provisioning a public IP address, creating that load balancer, and creating all the configurations for that load balancer in terms of backend pool, health checks, and the load balancing rules. So sometimes that takes a little while. It didn't take very long today, which was nice. So that is an example of a standard basic load balancer, because I used a basic cluster to do it in. I have a more advanced cluster, which is PA2. I gave PA2 all the cool stuff. So I can apply the exact same configuration to PA2, and it will create, oh, it already had it. Well, there we go. So nothing changed. I never deleted it. If we go and look at the resource group for that one, a couple things to note. I mentioned availability zones a while ago about when I was talking about availability sets. Availability zones are basically different data centers in an Azure region, and each one is a separate availability zone. So the idea is if a particular data center goes down, you still have functioning resources in the other availability zones in that region. And availability zones are now a preview feature for AKS. So if your AKS workload needs to be super highly available within a region, you can take advantage of availability zones, which this particular deployment has. What's the best way to show that? Well, I guess we can look at the virtual machine scale set. Does that tell you which zone it's in? No. Yeah, this one does. Yeah. So this node pool that I deployed, if you look at the location, it tells me it's in East US 2, and it's also in zones 1, 2, and 3. So each of the 3 nodes is in a separate availability zone. So if a whole data center goes down, I've still got 2 functioning nodes in here. Because of the availability zones, it requires using the standard load balancer instead of the basic load balancer, because I believe, and you correct me if I'm wrong, the basic load balancer doesn't support availability zones. So it has to use the standard.
I think so, don't call me.
So when you create a load balanced service on something that's using availability zones, you can see that the SKU for that one is standard instead of basic. So it's actually going to be a little more expensive from a load balancing perspective than using the basic, but you're getting the increased availability of that particular deployment. And then the last thing for networking is the internal load balancer example. So this is essentially the same deployment that I did before. The only difference is within the service, I've added this annotation that says service.beta.kubernetes.io Azure load balancer -internal true. And I'm basically just telling it I want an internal load balancer as opposed to a public-facing load balancer. You can also specify what subnet you want that to be provisioned on. By default, it uses the same subnet that the cluster is running in.
If you are deploying AKS inside of a VNet and you don't want it exposed to the internet, learn that line of code, bookmark the page, deploy your custom.
Yeah, I wouldn't expect anybody to memorize that. That's not an easy
It's
thing.
just one of those bookmarks I have because I always have to look at it.
I would put it in
As
one
much as you
configuration file and then
Microsoft
copy and
default.
paste.
Yep.
Let me see if I
It
got
also
any.
goes back to your IP address counting thing too. If it's VNetted off and you use something like Azure CNI, know how many you have, know how many you're going to need, know how many you think you're going to be adding on top of it, and if it's a shared cluster, you all have to kind of have a centralized discussion on what is our max that we can support in the cloud.
Yep.
I mean, this is just your normal planning stuff, but things to think about.
If I run that configuration, it'll create the service and the deployment, and then I can do kubectl get service, and it hasn't actually finished creating the load balancer. So if I do -w on that, it waits and shows me every time the information about this changes. So you see that internal app load balancer, it has a cluster IP, but the external IP is still pending. That's because that internal load balancer is being created right now. If we're really lucky, we can go over to here and refresh. And there we go. It has successfully created that internal load balancer and given it a private IP address of 10.240.8. We go back to here. It should refresh in a moment and give us that same external IP in this interface as well. So that now you've created a service and you've exposed it internally, but you haven't exposed it to the larger, wider world. So if your intention is not to expose your service to the larger world, memorize that annotation, use it, love it, live it.
Also, pro tip, that -w, you will end up using that a lot.
Yes, because a lot of times you're waiting for something.
I wish file that under things I wish I knew to do back when I started doing it, Kubernetes stuff.
Yeah, I watched somebody else do it in a demo, and I was like, ooh, that's the main takeaway. Not everything else the guy told me about Kubernetes, just -w.
There's
Got
another
it.
way. Isn't there a watch command in like Bash that you can then give it the rest? Not like in this scenario, but you can
Probably.
plug a watch command into it and then just have it.
As a Windows guy, this is all a mystery to me.
There's more than one way to do this, but this is the easiest.
There we go. So it finally came through, and that external IP, it's external to Kubernetes, but it's not external to the rest of the world. It's using an internal IP address in your VNet. So hopefully I answered all the networking questions that you had. Does anybody else have questions in regards to networking and AKS?
Are you at all able to assign them if you wanted to? You're able to dictate what IP addresses they get and what range they get them in?
For the internal load balancer?
Yeah.
Yeah, absolutely. So you could specify what sub then, and I think you can actually specify the individual IP address you want it to have if you want to get that granular about it. And that could be for like a DNS purposes.
Yeah.
Cool. Then I guess the only other thing is storage. Storage is magic. So I mentioned before, there's basically two different storage types that are used within AKS. One is Azure Managed Disks, and the other one is Azure Files. Before we look at that, if we look back at our good old cluster, we can look at this. No, this one's using VMS, so it's not as obvious. Let's go look at our very first cluster, our good friend over here in East US. Like that. And we'll sort by type. So when it creates your virtual machines, each virtual machine gets assigned a managed disk that it uses for its operating system. That OS disk is by default for at least for the Ubuntu Linux nodes is 100 gig. So if I spin up 3 nodes, I'm now using 100 gig of managed disk, and you'll notice that it is using premium SSD for storage. So you've got 300 gig of premium SSD that you're using. Obviously, premium SSD is the second most expensive storage. There is Ultra SSD. That's in preview. But it is it's more expensive than standard SSD or standard HDD. So just good to be aware, the more nodes you have, the more storage you're using, even if you don't have any volumes created within your cluster. Now, in terms of adding storage within your cluster, just a quick primer. We'll start with Azure Disk. So Kubernetes has this concept of storage classes. So you can have one or more different storage classes within your cluster, and each storage class has some definitions to it and has some information about how to provision storage for that storage class. So I can do kubectl get storage, if I could spell storage class. And right now in this cluster, I only have 2 storage classes. I've got the default, which is using Azure standard managed disks. So it actually uses standard HDD storage. And I also have managed premium. So those are my 2 storage classes that I can ask for a volume to be provisioned for my for a pod. The way that you actually do that is through what's called a persistent volume claim. So you're basically saying, I would like a volume and I'm going to claim it. And then I'm going to associate that claim with a pod. So this will tell this, in this I say I want to use the storage class of default. So what it's going to do is go out and provision a disk. I'm telling it I want a 500 gig disk. So it's going to provision a 500 gig disk for me. And that's it. It'll just have a disk. What that disk is for, we determine a little further down when I provision an Nginx pod. And within the information for it, I define a volumes section. And within that volumes, I reference that persistent volume claim and say, hey, that 500 gig disk that I just asked you to create, I now want it to be associated with this pod. And then within the pod definition, or the container definition, I should say, I'm telling it I want to mount this particular volume on the /data path. So if I go ahead and apply path a. All right, so it created that persistent volume that I wanted, and it also created the pod that I wanted. And I can do kubectl get PVC for persistent volume claim, and it'll show me that that claim is actually pending. So I can do, oh, there we go. So now it's bound. So when it was pending, it hadn't provisioned the storage yet. Once it moves to bound, now that storage has been provisioned and it's bound to a pod. If I go back to the portal and I take a look at that resource group, and let me just scroll down. There is, of course, it's not going to show me the storage account. Oh, there it is, dynamic PVC. So this is the disk that it just created. It created a 500 gig standard HDD disk in that resource group, and it's now associated with one of the pods within the resource group. If I want to get rid of it, I can do a delete, and it will delete. So I just sent it the same configuration with the kubectl delete command, which means it deletes the pod and deletes that persistent volume claim. And by default, and this is probably important to know, when you delete the persistent volume claim, it also deletes the volume. Maybe that's what you want. Maybe that's not what you want. So in some cases, you might want that volume to stick around even after you've deleted the pod and the volume claim. If that's the case, you can create a separate storage class on here using the same storage backend and provisioner, but with the additional setting of retain after the claim is deleted. And then when a claim gets deleted on a pod, the disk will continue to live on, and you could attach it to a different cluster or attach it to a different pod or whatever you want to do with it. But by doing that, if I go back here and refresh, it should say in a moment that the disk has been deleted. There we go. Okay, so it's out of the resource group. That disk has now been deleted. Let's say that I wanted to use a premium disk as opposed to the default disk. I can change the storage class in my persistent volume claim to managed premium and just save that example. I'm going to go reapply that configuration. Now we'll go out and provision a premium managed disk instead of a standard managed disk. If I do get persistent volume claim, I can see that that volume claim is complete and that it's bound. And I should be able to go back to the portal and refresh. And here we go. A new disk has appeared in my resource group. I can see it's 500 gig and it's now using premium SSD instead of standard HDD. I believe you can also use standard SSD, but you have to create a storage class for it. So let me delete that before I forget. Okay, I delete it. Now it will delete that it will delete that disk out of Azure. The other one that I mentioned was Azure Files. That's a little bit different. First, I need to change my context a little bit. Config set context PA1. There we go. Make sure I'm actually using. That's set context. That's probably why I'm using the wrong. Use context. That's what I wanted to say. That's why I love help files. Okay. Now I'm back on PA1. So in order to use the Azure Files, I had to create a storage class that's associated with Azure Files. And so there's instructions for creating that storage class on the docs site. Pretty easy to find. So if I get storage class here on this PA1 cluster, you can see I have Azure File in there as a storage class, and also Azure File Premium. So you can either use the Premium class or the regular class of Azure File. The registration process is this. You create a storage class and you define information about that storage class. Like I said, this is all in the docs, and you tell it which SKU to use. So I'm telling it I want to use standard LRS, and then I actually have a second storage class here defined for Premium. So I define both of them, and you give them names. So I call it Azure File Premium because I'm very creative. And then you have to create an RBAC an RBAC cluster role and a cluster role binding so it can do the persistent volume stuff. But that's deep Kubernetes stuff we don't need to get into. If I actually want to use it for that persistent volume, so this is basically exactly the same as the persistent volume that I used for managed disk, but you'll note that the storage class in this case is Azure File Premium instead of default or managed premium, and I'm creating the same Nginx pod information. So before I do that, kubectl get pvc. Okay, I don't have any volume claims at the moment. Kubectl apply -f. We'll do the Azure Files example. All right, so it created that persistent volume claim, which is going to use Azure Files, and it created the Nginx pod. So if I do get pvc, the status right now is pending. So it is in the process of creating the volume on an Azure File Premium subscription. So we can put that in a wait state. Oh, there we go. It's bound now. So we can go back to that resource group and see what it actually created on this side of things. Now remember, this is Azure Files, not Azure Managed Disks. So it actually creates a storage account. Is this the one, or there's two of them? Because I've done this before. Okay, so this is the premium one. So you can see the performance here is premium. And if we look under files, we'll see there's one file here. This is that persistent volume claim, and that it is 500 gig in size. So that's basically what it created. Again, once I delete that persistent volume claim, it will delete this file out of Azure Files. What it won't do is delete the storage account that it created for the cluster. So the next time you ask for it to provision a persistent volume claim for Azure Files or Azure Files Premium, it will use the existing storage account in your cluster to provision that file. So that's nice that it doesn't have to recreate a storage account every time when you get down to no files in a storage account. And I don't believe there's any charge for just having a storage account that doesn't have anything in it. So you're not getting charged there. It's just a convenience type thing. If we wanted to instead use just standard Azure file instead of premium, hold on, let me delete this. All right, and then save it. Okay, I'll apply the same configuration. Look at the PVC. That was very quick. Now we can go to that other storage account, which is just a standard storage account using standard performance tier. If we go and look in files, there's our 500 gig persistent volume claim in those files. Like I said before, it's also possible to provision storage using your own NFS server. So if you want to stand up an NFS server in the same VNet or a peered VNet as your Kubernetes cluster and use storage off of that, have at it. There's also Azure NetApp files. I don't know if anybody has heard of this. So Azure partnered with NetApp, and NetApp actually put their hardware in Azure data centers, and you can provision it through the Azure portal. That is also supported as a target for storage. If anybody's feeling particularly interested, I may or may not have done a whole blog post about different storage types. Yep. So if you go on my website, nedinthecloud.com, I have a whole layout of NetApp files versus Azure Disk versus Azure files, including some performance benchmarks for the different types of storage. I got another post that I have to do that adds some caveats to all this. So, but if you're interested in picking a storage target for your Kubernetes cluster, this could provide some information about which one to pick. So that's pretty much storage. Does anybody have questions about storage, provisioning, how it's set up in Azure?
I have a question. I'd say the file is really a folder, right? When you say provision a file, really you provision a folder and space, like say 500 gig, is that right? You can put
Right, it's
anything-
provisioning a folder with a quota associated. Thank you for clarifying. Yeah, so it's saying this is a folder that has 500 gig of space associated with it, and then you're giving it a mount point in the pod where to mount that storage. And Azure Files is actually really performant, is what I found out, especially the premium tier. The only thing you have to keep in mind about the premium tier of the storage is the performance you get is dependent on how much storage you've provisioned. So every additional terabyte of storage adds like 1,000 IOPS to what's possible with that particular storage volume. So basically, the bigger the space, the more performance you can get, but you're paying for that space, obviously. So I discovered that quickly when I provisioned only like 500 gig, and I was getting okay performance, and then I bumped it up to like 2 terabyte. And I was like, oh, okay, so that's a little bit different.
That's the way premium storage works.
Yeah.
It was a terabyte drive just for IaaS stuff.
Mm-hmm.
And in order to get the IOPS that we need for our 200 gig worth of temp file,
Yeah.
database server, we had to get about 2 terabyte space.
Yeah. It makes sense because it has to spread that performance across however many spindles or
Yeah, I mean,
whatever
you're paying for the IOPS, but you get the space and the benefit. You can think of it that way.
you're paying for the apps, you get the space for free.
That's right.
Or something like that.
Backup, because do these machines back up?
As far as I know, they're not integrated with Azure Backup. So if you want to back up the data that's being stored on these file shares or the disks, you're going to need to include them in some way in taking snapshots for the managed disks or whatever the equivalent is for Azure files. So yeah, good question. you're still responsible for backups. That part is not managed.
Right. And you have to consider when running, when you say, okay, I'm going to get into containers, I'm going to run AKS, and I'm going to have data and everything like that. What are you responsible for? What is Microsoft responsible for? What do you need to back up? What should you be backing up versus what comes with your managed service, where Microsoft will take care of that. You don't have to worry about this part. But okay, my data over here I got to take care of, or this, right? It's part of your larger strategy. You need to think about what you need to back up, where you need to back it up. Also, same thing with the availability, right? Do I need local? Do I need regional? Do I need to go worldwide? Is this going to be deployed in multiple spots around the world? How am I going to deploy out to all of those things and places and do it in a manner of that? There's also a whole other conversation, which we may talk about during the labs, which is your deployment strategy for each thing that you push out. How does that go? How does it work with the nodes, draining the nodes, porting them, spinning up new nodes, pushing them out, how to do that zero time downtime and do it in the round, things like that. There's a whole lot of things we can get into that I don't think we're necessarily going to touch on tonight, but just think about it, because we can ask those questions either towards the end of the hands-on labs if we have questions around it, or if there's enough interest, another session, maybe we would do a dev and architecture session around this. There's plenty of material out there for multiple meetings at this point.
Yeah, my goal was really less about what's happening inside Kubernetes and more about what's happening in your Azure environments when you're using AKS, because it's not just spinning up a black box cluster that you have no insight to and you're not responsible for any of the components. There's still a line of delineation there, and you need to plan out things like IP addressing. How are you going to work with storage? How do you want to integrate this with the rest of your environment from a networking perspective? What family of VMs do you want to use? What level of performance suits you? So there's a lot of questions that happen at that level, and just things to be aware of what's actually going to exist in your Azure environments, especially if you have compliance and policy restrictions in place. You're going to want to know, that things are tagged appropriately, that they're in line with whatever policies have been pushed down from the administrative group. So there's a lot going on just in Azure, and then what's going on inside Kubernetes is like a whole other day or multiple days. It gets complicated quick. But I think that's everything that I wanted to cover today. So I'll open up to questions. Yeah.
So with volumes, or even with the VMs internal disks, if you use it for file storage for temporary files, is there a way to run a scheduler on it to clean that up?
Let's see. So for the pods, they do get a certain amount of local disk space that's just inherent to the pod when you provision it. The persistent volume claims are to create a volume that is outside of the node to persist data. If that pod were to die on that node and come up on another one, it would reattach to this volume that exists outside of it. So within that particular node, you can specify, I think you can specify in the pod spec, a volume that lives on local storage, and when that pod dies, that storage also gets wiped out.
Right, I'm just wondering about the temporary thing, so it doesn't build up and you end up using up your 100 gigs of the VM. I mean, is there a way to go in and make sure that these temporary files are getting cleaned?
I mean, I'm not sure about that, Tim. I think when you add additional mount points for your container, you have to specify how much storage space, and the scheduler is going to take a look at that and see how much free storage is available on the worker nodes. And if it doesn't have the free storage, it might just go, no, sorry, I've got no available storage on my nodes, so I'm not going to schedule that pod anywhere. And like I said, when you kill that pod, it's also going to kill the underlying storage claims that are made on the node.
That's a good question. That's something that you're going to have to plan in, because you're going to have to basically think to yourself, I'm doing a lot of temporary data manipulation, and where should I do that, and does it need to persist? And if not, then you need to look at how big your node and your pod and the max amount that you would have, or if that's your concern, do you immediately just go to an external mount and have that be your swap space, and then clean that up? That way your pods can live and die, and doesn't matter. That will still be there, even just as temp space, but that way you're not worried about affecting your cluster
Right, and I haven't looked into it, so I'm not sure if you can specify a different disk size for the worker nodes. So there may be a way to do that through the CLI. I haven't tried to dive into that to see if that's possible.
At this point, you're talking about doing something within the software, within the container that you're running, so you could always have that be what you want to look after it, and then if that way either your container also knows to run the script to finish when it's done, or you've blown it up essentially, and then the container will just die and it'll just come back anyway as another one as an empty. It's not the way you want to go, but it's containing.
I'm just imagining each one like inflating and then exploding, and then a new one takes its place.
Which you will also notice if you monitor your farm and you see it continually spinning up. That's a classic sign of runaway of your code.
Well, if it's bad enough, then it'll kick on in the back off policy where it'll stop creating that container for a certain amount of time, and then try again a little bit later. So yeah, you don't want that happening either.
Did you show the dashboard? Or did you talk about monitoring at all?
No.
I missed this. Okay.
I did not talk about monitoring.
You definitely want to have a monitoring strategy involved in
Yes.
this as well. And that's where you would either be notified of continual, like if your pod continually turns on, or your container continually turns on, has an error, and fails out within a relative amount of time, your pod status at most times, if you just did a quick check, would say, oh, my farm is healthy. My pods are either good or they're initializing, right? They're coming up. But you would also notice that, hey, everything looks good, but I've spun up like 100 in the last 20 minutes. That would tell you there's something wrong, but it's not like not like an error. Your pod wouldn't be in an error state because it keeps crashing and coming back new. So that's just one of those things you have to know to look for.
I know you can hook it into log analytics. That's
Azure
part of the
Monitor for
wizard.
Containers.
Yes.
Is that? So that's the
But then there's the
Kubernetes dashboard, but
the what?
the dashboard itself,
Yeah.
the Kubernetes dashboard.
If you go to the dashboard, you've already lost.
There are other ways of doing it that you would need to consider.
Yeah,
Azure
and
Monitor.
then there's like I won't say native, but the very common Kubernetes logging and monitoring tools that are out there. Prometheus is a very popular one, so you can always set that up as well. So I guess it depends if you want to go all Azure, all native, or if you want to use some of the third-party tools for your monitoring.
Could you write a sidecar that groomed that storage space for
Sure.
old files?
Yeah, I imagine so. It is a shared space. You'd have to give both of the containers that volume mount. But yeah, I assume you could have that just being the garbage collection service that functions outside of that. And then you could write a really good garbage collection service that you can attach as a sidecar to any of your applications that need it. So yeah, that might be a good instance of having a sidecar as opposed to including it in the image itself.
You briefly discussed what a sidecar is. You mentioned sidecar proxy as well. Give a little brief
Sidecar is
of that.
just like a way of it's just an
process.
additional container that will be part of the pod that's performing some function that should be logically separated from the other container, but it makes sense to pair them in a single pod space because they do share that inter-process communication and the local networking. Another instance, so if anybody has used HashiCorp Console, they have a console agent that you can deploy as a sidecar to all of your pods that need to talk to the console cluster, and it handles all of the cluster communication and just presents itself on the local port 8300 or something for the application in the other container to use. So it doesn't have to know anything about the secrets management or the encryption or communication back to the console cluster. It just talks to a local port instead.
I have a question. Say I'm from traditional IT things, we have developers, and then we have the infrastructure team. Assuming your topic more geared for infrastructure team, there's one setting up Kubernetes containers, VNet, IP address, balancers, that kind of stuff, right? We're adding a more desk and space for developers. Is that true, or
I would say
rules? I mean, like what's the part you want?
Right. The question is, where does the sort of
Yeah,
responsibility begin and end between the developer and the infrastructure team. And it's kind of blurry when it comes to this, because as a developer, you can provision infrastructure in Azure by just putting it in a configuration file in Kubernetes. You can say, I want, 100 500 gig persistent volume claims. And obviously the infrastructure team has to be somewhat aware of that and be able to support your requests. So because you can have a direct impact on the infrastructure within Azure, this is all good stuff for a developer to know, even if they're not necessarily planning out the IP address spacing and doing the patching and maintenance of the Kubernetes cluster on an ongoing basis. Yeah.
The infrastructure, the new mindset might be that they're setting the policies so that you can't create the wildly expensive VMs, and then you're getting the messages that you've been blocked from doing so, and you go talk to them, and you're back
Right,
to
or
the
you just
same.
don't fat finger something and put in 500 when you meant to put in 5 or 50 or something like that. Yeah.
This is a great example of where infrastructure as code makes a ton of sense. Not that it doesn't make sense for other things, but in this especially, where you could do infrastructure as code, you would check in your YAML files with your code in your repository, have an approval process there, have more than one required, so you have multiple sets of eyes looking at this. That way, not only do you see it and approve it, the infrastructure team would see it and approve it. You could put a pull request in to merge that into master. Then you could get into the whole, you could use Azure DevOps, and it could then kick off and make the update for you. But at least the beginning part where you say, look, if this was as code, we would then have an approval chain around it, and anyone who said that they needed to be involved in that would see the change. And that is a way to get both sides, the devs and the IT ops team together, to at least collaborate and know what is going on.
I said we weren't going to talk about CI/CD pipelines and branching strategies, and yet here we are. Just the world we live in, right?
There's no way to get away from DevOps at this point.
I know. I didn't even use the word DevOps the whole time. I was doing so well.
You talked around that?
I talked around it.
This makes perfect sense for DevOps, that's all I'm saying.
There's nothing wrong with DevOps. It's one of those abused terms these days. Everybody's doing or are DevOps. I don't know what that means anymore.
In this case, it makes total sense.
It does actually make total sense to have a nice integration between the infrastructure and the dev team, so that you're working hand in hand to make sure you're using the resources responsibly and you have the resources you need and the policies in place so you don't shoot yourself in the foot.
And since we have the time and we're on the topic, that is also where you would integrate the security concerns and things like that, where you would have your code scanning tools hooked up to your repo, your GitHub or Azure repos or whatever. You would also have in your pipelines scan your containers for vulnerabilities and things like that. These are all things that you need to think about and need to automate. You need to check if there are changes to the, scan your containers before they go to production to see if there's vulnerabilities, but you also want to have something monitoring the underlying container, right? So the part that's a lot of times is glossed over is you base your container on an underlying image, with the Nginx base image or the Outline or the .NET image. Those are images maintained by someone, normally the company, but there are images that aren't by those companies. When they make security updates, you need to have a strategy around rebuilding your containers based on the latest updated image that was put out by those vendors.
There's
these are all things that
you could use Azure container registries with build tasks to detect that a newer version of the image is available and do an automated patch and build on that. I mean, you could. Just saying it's a thing that exists.
Did you get into patching and updating the infrastructure itself? So like what part Microsoft is responsible for to patch, what part you have to schedule the restarts though?
No.
Okay.
I was avoiding that.
We won't get into that, that's fine.
Yeah, I was trying to keep it, strictly my little.
Well, this was I know.
My
You
little
did a great
selling
job,
bits.
and this was the idea.
I also thought that there might be another presenter. I didn't want to go way over on time, but now I see that's not the case, so I can just ramble as long as I want.
We only got 14 more minutes. So.
Well, at this point, I think I'm just keeping people away from beer. Or wine. Or water, whatever, your beverage of choice is.
How do you set up prod, non-prod environments? How do you migrate those?
I would say the most common deployment right now is to have one cluster that's for non-prod and then a totally separate cluster that's for production. Because you do want that hard separation. And then another common pattern is that you have one repository of artifacts that is your non-prod, and when you promote something to prod, it gets copied to a separate artifact repository. That is the only thing that is allowed to be deployed to your production cluster. So you can put basically a gate in there that says, if the artifacts aren't coming from this particular repository, it cannot be deployed onto this cluster. So you can kind of stop anybody from accidentally pushing something that's sitting in QA or development to your production cluster because they fat fingered something.
You can do a lot of that with Azure DevOps or your choice of pipeline orchestrator, et cetera, but that is a way to do it. You can have it go all the way, push out to dev test, and then push out to prod, and have gates in place for approvals and all that. You can have separate pipelines just for prod from a different repository. So, you know, maybe your dev test pipeline does your builds, creates your container, pushes out the dev test, pushes out the QA, and then at the end of that, the deployment actually just gives you the container into somewhere else, where then you say, okay, once we have a blessed container and we say, okay, now it's in this container registry, let's do our pipeline to production. So there's multiple ways to set this up. There are multiple orchestration tools to do that.
Within one cluster, usually the way to set up different environments is to use namespaces. So you'd have a development namespace and maybe a staging or a QA or something that's specific to even a release or a feature branch or something. You want to have just a namespace for that feature until it's ready to go. And then they've also, there's a feature in preview called dev spaces that creates a common sort of development space, but then each developer can have a subset of that space where they can add their code updates, and only the portions that they've updated get created inside their space, and then it references the rest of the services in the larger dev space. So it lets everybody sort of iterate on a common base while still working on their individual features. That one's that requires some work on the coding side to get dev spaces working though. So that's not a grab it and go kind of situation.
It's super cool because you can like debug from like within Visual Studio to a Kubernetes cluster running in the cloud.
Exactly. Yeah.
And it's helpful because of, you know, a lot of times as a developer, even if you're working locally, then you're working on that local container, but a lot of times it's an integration thing, right? You can't just debug your part, you need the rest of the cluster. So dev spaces is a really nice way to be able to push your stuff up, integrate in the dev Kubernetes cluster with everyone else, still be isolated, but still have that part together. Because that's one of the things that you will run into as you go through your container journey. Realize, okay, we all just can't build our own single API and push it out there. There has to be that integration testing, and what can we do to iterate faster? And that's a nice helpful tool.
It's another way.
It's one of many.
One of many different potential strategies. Feels we covered a lot.
Is there any Azure Labs tie into AKS yet? Like actually because there was that whole Azure Labs thing to make it easier to spin up VMs without waiting on authorization from.
Talking about Dev Test Labs.
Yeah.
I don't know. Is there a dev test lab for AKS?
I don't know. If you're just talking about something that you want to do to learn how to do this, there's a number of options for this.
There is just like learn.microsoft.com that has some examples, and I think it'll spin up something in a sandbox for you, but I don't know if it's the full AKS.
Yeah, Dev Test Labs is like my IT department wants to give the developers up to 5 cores.
Oh, okay.
Their own little space, like it's a little walled garden kind of thing.
Yeah, that I'm not sure about.
It's not this, yeah, I don't know if there's a Kubernetes dev
I think
test.
most folks are just setting up a Kubernetes cluster and saying, here's the dev party cluster party.
Right. And if you're just trying to learn Kubernetes in general, there's a bunch of different free online resources that'll spin up a temporary cluster for you. One's like learnkates.io or something like that. You can search it. But it basically just play with Kates. Maybe that's what it is. I think that's what it's called. But basically, it just creates a temporary Kubernetes setup for you that you can mess around in, and it's got some exercises that you can go through So if you're just trying to familiarize yourself with that, that's a pretty free, easy option. It's hosted by the same people that do Play with Docker.
And if you want to learn how this works with DevOps and CI/CD pipelines, it's Azure DevOps Labs, I think, .com, and that's where you'll get the walkthrough. You'll set up your Azure DevOps account.
Yeah, that's right.
Subscription.
Play with Kates.
And it will help you build your containers and then figure out how to push them out and things like that. So also a nice walkthrough.
Yeah. So yeah, if you go to labs.play-with-k8s.com, that's a free lab. You just need a GitHub or a Docker login, and it spins up some resources for you. You've got 4 hours to play with them, and then it time bombs them when the 4 hours are up. But yeah, if you're looking for a totally free way to play, that's what I used for a little while.
For developer perspective, what kind of apps is best suited for the Kubernetes environment? Not all of them.
Well, I mean, it depends on who you ask. So generally speaking, the stuff that people talk about most are, stateless web type applications, middle piece applications. Most people are still using something else for the back-end databases, but that's changing. So like you can run a SQL Server, was it 2019 or 17 or whatever, in a Kubernetes cluster on Linux using persistent volumes, and you can set up a pretty performant cluster doing it that way. So slowly that is evolving, but right now most people are using it for the web front end and the middle tier.
And microservices. So
Yeah.
APIs. That's
For the Microsoft APIs, what's the architecture wise? Anything special need to be done building the Kubernetes cluster, or it's a vague question, sorry, but still
no.
anything,
If you're
there's a lot
looking
of
to
talk
do,
about microservices, just wondering how does that help the Kubernetes point of view?
it's the reverse. Kubernetes helps you. If you are going to microservices, a container, and you're doing it in containers, then a container orchestrator, such as Kubernetes, AKS, those are where you're going to want to look to help you, because you are going to be managing a ton of microservices, all these APIs, and you're going to want a way to have them all be pushed out and dealt with. So
right. When you think about the typical model, you would have a deployment, and the deployment is creating a replica set, and then pods within that replica set, and it's managing that. And then you have a service that you associate with that deployment, which then makes that service available either within the cluster internally as a service or to the larger world, depending on how you want to have it set up. So in a microservices type architecture, each microservice is probably going to be composed of a deployment and a service that work together.
What about API gateway and things like that, when you add to that, does that work with that? Or?
Yeah, you can definitely hook it into an API gateway. So the way that you expose the service depends on what type of service you're trying to expose. So we saw that you can use a Azure load balancer to do it. You can also do a layer 7 application proxy using something like Nginx. So you could put that in front of this other service, or you could set up some kind of API gateway for multiple services that are referencing that. So yeah,
it's going to be a tier, right? So you're thinking, okay, I have a microservices architecture. What is a great way? One of a number of ways. What is a great way to help me manage and do that out, right? So, okay, great. I've got containers. Cool. I know in this scenario I want to use Kubernetes because of all the things I get with Kubernetes. So I've made that choice. Then the next one, well, I want a managed Kubernetes instance because I don't want to run and patch my own. So now, AKS. So we move to that part. And then you go, okay, now we're going to do microservices. How do I manage all of them? So we'll use Helm charts to push them all out. And then that way it is being taken care of by Kubernetes and AKS to watch them, manage them, make sure that they're up, check them. If they go down, spin them out, and I have my deployments. Then I can go to that next level where I go, okay, I have this out, I've set up my load balancers now, I've got my service. Okay, now I need to expose them externally. I want to use the API gateway in order to have that be the front end of these specific ones that I need to expose out. So you're just building on top of each other and determining what you want either to make easier by Kubernetes, what you want to let Microsoft handle, what do you want to not have to do yourself, versus what do you want to spend your time making sure that it is done correctly. So you're just kind of building up on top of this until you have a nice architecture that you can focus on the things that you need to focus on and kind of let the other stuff take care of that for you. You don't spend your time monitoring VMs or checking deployments, things like that, right? You can kind of move to that next step and let the cloud handle that.
Question for that architect: do you have a tool to diagram all your containers, whatever?
Trying to map out how your containers.
Yeah, so you have a big architecture. I mean, whatever you involve, right? All the containers and VNet and service. Do you have a tool to diagram this thing?
You're asking if I auto-generate it, or you're asking
I
what
don't
I
know.
would use to draw it out?
Something, right? I mean, you present it to teams that here's our.
Well, I would draw it in Visio if I was going to do it manually. If you deploy all this first and then hook up like Azure Monitor and you use application insights for your app, you can actually have it auto-generate some of your network patterns for you, and that actually helps you diagnose issues. That's just one of the features of Azure App Insights in Azure Monitor. But to your ask, I don't know if there's something that just auto-generates that entire architecture. I would probably have drawn it out first and said, this is what we're going to do.
I think there's some infographics that explain all the different components that go into AKS and how they interact, which might be informative, but to actually diagram out your particular environment, that's going to be somewhat of a manual process.
The application insights tie in fairly early on in the process where you could send your logs there.
Mm-hmm.
Is that the Kubernetes logs or is that the application logs?
Yes.
It can be both?
It can be both.
Okay.
The whole point of Azure Monitor is that it's a combination of infrastructure monitoring and application insights. So you can instrument your application to send information there. You can also have Kubernetes send information there. I think when you hook it into a log analytics workspace, it's sending the container logs there as well.
So Azure Monitor is now like an umbrella for a lot of monitoring solutions, right? So if you were going to do this, you would use Azure Monitor, and it would take care of some of the networking and infrastructure part. There's part that is dedicated just to your containers. There's the App Insights part of Azure Monitor, because it's all rolled together now. That would be for your code. All of these would be sent to your Azure Monitor instance, where you would then be able to make a nice, pretty dashboard that shows you, here's where the networking is, here's the code part, here's the underlying infrastructure, here's the containers. Now I have a view of what is going on. So we are at time.
We are at time. Well done, everyone.
Perfect timing. Thank you, Ed.
Thanks for coming. This
As
is a
Ned
good
mentioned,
thing.
we're going to have a hands-on lab next month. The Meetup post should go out tonight or tomorrow morning. So keep an eye on that.
If anybody wants to say hi howdy on Twitter, I'm Ned1313. Easy to find.
I'm sorry.
Feel free to